So, welcome students to the first lesson of 4 in the course concerning biomass for energy and bioenergy integration in the energy system. Opposed to some other renewable energy sources, such as wind, water and solar radiation, is bioenergy a source that can be stored. And the biomass itself is a solar energy storage. So while wind, water and solar energy must be momentarily converted to an energy carrier, such as electricity or heat, can biomass be stored as it is, or it can be converted into a biofuel that can also be stored, and it can be transported, and it can be used at a later instant and at another place. You may get an idea of this if you look at the RES change page as linked from the Bioenergy Prof homepage. The link is found in the same page as where you find the BusyPlan handbook. If you forgot where to find the material, then retake the second introductory lecture to the course. Now, biomass can also be converted and refined to produce, for example, liquid or gaseous fuel. The fuel can then be transported and stored and used at will at any time and any place. Biomass can finally be the source of biorefinery processes to produce fine chemicals with energy carriers as a valuable side product. The first lesson in this course is dedicated to the biomass itself. You may think that biomass for energy is equal to energy crops grown in fields. This is a very common misconception. As you will learn first in this lesson, the growth of biomass is slower than you might expect, and the size of the earth is limited. So we do not want to make use of dedicated energy crops unless they are integrated in a crop rotational scheme. Instead, must the use of biomass for energy purposes be limited to use residues, or it must be marine so as not to compete with the availability of land. The residues may originate from agriculture, or from forestry, or from food processing, or from sorted waste fraction, or from society, or from cattle, or from humans, or from, well, whatever. And biomass specifically grown for energy may in the first place originate from seawater algae farming. Depending on the origin of the biomass, one may distinguish 3 major types. Some biomass has cell walls. This group includes forest residues and a number of others, and is called lignocellulosic biomass. Some biomass has no cell walls, but is still composed from cells. This group comprises some of the marine biomass and food residues, together with, for example, fruit biomass and other types. And some biomass is not made up from cells at all. In this group we find residual oils, animal droppings, waste paper, and human feces, just to mention some. Depending on the most fundamental structure of the biomass, it is better or worse suited for different types of processes. Biomass with cell walls is best suited for thermochemical processing, like direct combustion, or gasification, or torrefaction, or pyrolysis, or liquefaction. These types of biomasses can be stored typically without much problems. Biomass without cell walls is easily degraded and is best suited for biochemical conversion processes. If the biomass is rich in sugar, like most fruit biomass, it is best suited for fermentation. But then these biomasses are likely to start degrading already during storage. And if there are no cells at all, such as vegetable oils, the best option may be to just stabilize it, using a cold chemical process like esterification or so. Some biomasses, like organic waste and food scrapings, can create major sanitary problems while stored. Some biomass may self-ignite, and so on. Different processes will be treated in more detail in the next lesson. So this first lesson will give you the outlines to biomass as such. We will talk about the photosynthesis process, and then we will talk about the living cell, about cell walls and cell membranes. And then we will talk about which different biomasses can be found in different sectors of society. Finally, you will be asked to do a simple resource inventory in your own home region and to document that in a short essay or as a short film or in any form you find appropriate. The aim of that final exercise is that you shall demonstrate that you have learned to look for useful biomass and that you have overcome the common misconception that the use of bioenergy requires dedicated bioenergy crops grown on agricultural land. So now go on to the first nugget, the one to introduce photosynthesis.